Hello and welcome back to another fun lesson in geometry. We're in chapter 10, section 3. We're talking about using chords. A chord in a circle is a segment that has endpoints on the circle. So the diameter is a special type of chord that goes through the center, and any other chord divides a circle up into a minor arc and a major arc. The diameter would split it into two semicircles. All right, we're going to look at a few theorems here because there's some really cool elements of chords. So first off, if two chords are congruent, then the arcs that they form are also congruent. If a chord is perpendicular to the diameter, then the parts are congruent, which means it's a perpendicular bisector, right? So this part, this segment up here, F to H, is congruent to this one. So the diameter is a perpendicular bisector of FD. And the same way the other way around, the converse, if it is a perpendicular bisector, then that has to be the diameter. So if this segment is congruent to this one, and we have a right angle, then this SQ must be the diameter. Alright, using the information we know now, okay, two chords, if they're in the same circle or in congruent circles, then they form, if the chords are congruent, they form the same arc. Alright, these two circles are congruent because their radius is the same. The radii are the same. So that means that measure FG, since the chord is congruent, must be 80 degrees. Measure FG is 80 degrees. That's how easy that is. Okay, if we want to use a diameter here, and we know that this is perpendicular, then we know these two segments, the diameter is a perpendicular bisector, so this must also be 7. So we want to find HK from here to there, which means 7 plus 7 plus 7, and that gives us 14 for HK. Yeah, 14, come on. Alright, next we want to find the measure of HK. So from here to there, we know something about this arc and this arc. Since the diameter is a perpendicular bisector of HK, then it also bisects the arc HK. So therefore, HJ, the arc HJ is equal to JK, because this is a perpendicular bisector. Alright, and so we have 11x is equal to 70 plus x. And we'll subtract x. 10x is 70. X equals 7. Alright, so we plug 7 in here. 11 times 7 gives us 77. That means this one's also 77. So together, 77 plus the 77 gives us 154 degrees. Alright, 3 bushes are arranged in a garden as shown. Where could you place a sprinkler so that it is the same distance from each bush? Okay, this one's a little bit tricky, but it has to do with what we've been doing in this lesson, obviously. So we have to somehow have an arc, right, that goes over each of these, and in order for them to be the same distance from the center of the circle, that has to be a perpendicular bisector. So what we're going to do here is we would connect these like so. Then we would have to find the middle, and you can either do that by measuring or constructing. Find the center. Let's put a dot there, here, where this is congruent to this, and then construct a perpendicular line to those. Alright, so we have a perpendicular line here. Cha-ching. Same thing here, split this in half, where this side is congruent to this, and we're going to construct a perpendicular bisector. Whoop. This way. And then if we took this point right here, and we did a circle around there, we should be the same distance from everything. Now, let's see. Boom. Okay. Approximately. My construction wasn't perfect, but it was close. It's getting all the bushes. Alright. 10.9. Equidistant chords theorem. If two chords are the same distance from the center, then they are congruent. So, if this is the same distance, and the distance from the center would be measured by a perpendicular line on that. That's how I'd know what the distance is. Then those two are congruent. Very nice. So we'll use that right here. So we know that QR is equal to ST. Alright? That tells us that they are the same distance, which means we already know 2x is going to be equal to 5x minus 9. Alright, and ST and QR are 16. We know CU is 2x and CV is 5x minus 9. We want to find the radius. Now notice we don't have the radius. Well, we have the radius here and here, but we might not be able to come up with a way to find this one, so we're going to use triangles to find the radius. Alright, but first let's put in what we know. We know that Q to R is 16. Since we have the diameter here and it's perpendicular, we know that it's a bisector, so each section here must be 8. We know that 2x has to be equal to 5x minus 9. So we can solve here. Subtract 2, we get 3x equals 9, and x equals 3. Okay, so 2 times 3 gives me 6. So this is 6. Now if I want the radius, I already have two sides of a right triangle here, so I can use this Q CQ as the radius is R, and then we'll use a right triangle. 6, 8, that's a Pythagorean triple. 6, 8 makes this 10 is 10. Boom! There you have it. Ladies and gentlemen, good times. Check back again next time for another fun lesson.